Hello guys, welcome back to Scholastic. I know it's been a long time, but I'm back. So today I've got a question that one of my friends suggested because they need help with it. So here I've got a picture of it that I've sketched. Here is the actual question. I've done a little bit of working on it, but I'm trying to show you how I do it all from scratch. The first question says, show that the coordinates of B are 0, minus 5. On here, as you can see, B. So the equation of this graph is x squared plus y squared equals 25. Let me just fix up my camera real quick. So that means, because there's no extra bits, so the equation of any is x minus a squared plus y minus b squared equals r squared, where the centre of the circle will be at a, b, and the radius is going to be r. That means here we have r squared is 25, so the radius of this circle here is going to be 5. I'm not going to label it, but the radius is 5. So that means if we're going straight down 5 from here, and you get 0 from the origin, minus 5 is going to be minus 5. So that means it's 0 minus 5. The second question says, give a reason why PA is equal to PB. So ignoring my very adequate tangent skills, so these are supposed to be tangents to the line and to the circle, and they both cross at P. So the reason that these two are the same length is because of a circle theorem. So one circle theorem says that two tangents that hit the same point, P here, are the same length. That means AP is going to be the same as BP, and that is the reason why for part B of this question. Finally, part C, where you need to find out the coordinates of A and of P. So you start this off by, because we know that these are the same length and BP is supposed to be perpendicular because tangents are perpendicular to the radius, and of course this is a radius here, so that means whatever P's y value is, it has to be -5 because it is going to be perpendicular and the x-axis is perpendicular to the y-axis, so they're going to be perpendicular. So how do you find out this x value? So what you have to do is you need to find out this line, like the equation of this line, or well, just a gradient of this line that connects A to P. And how we do that is, so we have, first up we need to find out the equation of this line here coming from the centre to A, and that is going to be 4/3. As this is rise over run, your gradient is your change in y over your change in x. So then you just do 4 divided by 3 equals, well, 4/3. So that's that. Now, as I mentioned earlier, tangents are perpendicular to gradients. So tangents are perpendicular to radii, and this is a radius, this is tangent, so it's perpendicular. If it's perpendicular, that means you need to use the inverse reciprocal of 4/3, so that's going to be -1 divided by 4/3, and that is -3/4. That is our gradient that we are looking for. -3/4. And now armed with this information of our gradient and the full coordinate of A, we can actually find out the equation of this line here, which we can do like this. So y is going to be our gradient times x plus c, and as mentioned earlier, our gradient is -3/3 over 4, so we have -3/4 x plus c. But we have our point here, which means we can actually substitute that in, subbing in 3 for x and 4 for y, meaning that you get -9/4x plus c equals 4. Sorry, no x. Just 4 equals -9/4 plus c. And you add 9/4 both sides, you get 16 plus 9/4 equals c, or 25/4. Sorry about my camera. 25/4. So that means to graph this, y equals 25/4 minus 3/4 x. And now with this, we have the gradient, and we have this, and we have a y value that we can actually substitute in. So we do -5 equals 25/4 minus 3/4 x. And -5 is the same as -20/4. So you can actually cancel out all the 4's, and -20 equals 25 minus 3x. So we add 20 to both sides with a 0 equals 45 minus 3x, which can be rewritten as 3x equals 45. Using either a calculator, or if you want, you could do it in your head, get x equals 15. And with that, along with our gradient of, our y value of -5, that means we are looking at the point 15, -5. Thank you for watching this. If you want me to review any other questions, then I'll find some sort of way to answer them. But see you next time at Scholar Year 6.